Hey guys, welcome to Chemistry Hotspot. Today we will be discussing the classification of ligands. In previous video we have discussed the representation of the complex ion. In that we have seen that the definition of ligands, right? So in this video we see the classification of ligands. Ligands are majorly divided into two subdivisions, that is based on the donor or acceptor capability and based on the number of donating site or donor sites. So first let us discuss this number of donor sites classification. Based on number of donor sites, a ligand can be said as monodentate, bidentate, etc. In the name itself we can see mono, bi, tri, tetra. That means if it is monodentate means the ligand can donate a pair of lone pair electrons. That is, a lone pair of electrons is involved in donating of the electrons. In case of bidentate, two lone pairs are involved. For monodentates, some of the examples are fluorine, chlorine, bromine, iodine, water. Sorry, you have to say this as fluoride, chloride, bromide, iodide. Since the negative charge is there, you have to say in iodide, bromide, fluoride, chloride in that nomenclature. Well, this is for classification. Let us discuss about these examples. For bidentate ethylene diamine, you can give us the example, that is CH2, CH2, NH2, NH2. Two donating sites are involved. Here one site is involved, here two sites. These two nitrogen having lone pair electrons will act as the ligands. For for diene, here we have the structure diethyl triamine. En means that stands for ethylene diamine. DIEN, that is diene, stands for diethyl triamine. So here you can see one ethyl, two ethyl, diethyl triamine. So the number of donating sites will be 3. This arrow mark denotes the ligand donating. And the next one is triene. Triene involves 3 triethyl tetramine. The definition states for the triene triethylene tetramine. So you can find the triethylene groups and 4 amine groups, and hence the 4 donating site of nitrogen lone pairs. Then the next classification is ethylene diamine triacetate. So ethylene diamine 1, 2, 3 triacetate group. Here the number of donating site will be 1, 2, 3, 4, 5. For donating the electrons, either you should have a negative charge or you should have a lone pair of electrons. Each ligand can have either it have the lone pair of electrons or it have the negative charge. So these negative charges are always counted for 1, 1, 1, 1. So this is 3, then 4, then 5. Totally 5 donor sites. For this says the ethylene diamine triacetate. If you replace one nitrogen with another acetate molecule, you get the ethylene diamine tetraacetate. So this ethylene diamine triacetate tetraacetate or belongs to a group of ligands which is familiarly called as chelating ligand. Chelating ligand that defines that ligands which form a ring structure with the central atom. So with the central atom, these ligands form the ring structure. So these types of ligand are called as chelating ligands. So we have discussed the types of ligands based on the number of donor sites. So the next thing classification we will be discussing will be the number of donor or acceptor types. We have classified the ligands, right? So based on that we will study. So ligands can act as a donor ligand or a acceptor ligand. In organic metallic compounds, you will study this in deep, that like sigma donor, sigma acceptor, pi donor, pi acceptor, sigma donor, pi acceptor, pi donor, sigma acceptor, etc. These classifications and all you study there in deep. Here let's brief the classification. We will say that this can be further divided into based on the ligands having with lone pair of electrons without having lone pair of electrons, but it has the pi bonding electrons. Example may be benzene, ethylene. So with lone pair of electrons can be classified on again two types, that is no vacant orbitals having vacant orbitals. If there is no vacant orbitals, you can't get the back donated electrons from the metal. So if vacant orbital is present, then it receives the donated pi electrons from the metal. So metal, the condition should have that low oxidation state. Example for this type is water, fluoride, ammonia, and here trialkyl phosphorus, cyanide, or carbon monoxide. So carbon monoxide or carbonyl group. So these are the classifications of ligands based on the donating or accepting capability. So we have the another exception classification, that is Flexi Dentate Ligand, and another one is Ambidentate Ligand. Flexi Dentate ligands are those ligands which have multiple denticity in it, but a particular time either it acts as a bidentate or monodentate. If you consider this ligand, this will act as monodentate in some cases. In some cases, the same ligand acts as bidentate. So this type of ligands are called flexidentate. That is, they are not stable, they are flexible in their denticity. That a ligand which shows variable denticity are called as flexidentate ligands. The next one is ambidentate ligand. Ambidentate ligand are those which have more than one donating atoms, more than one donor sites. You can say either it one donor atom or more than one donating site, but at a time only one should be considered for donating the lone pair of electrons. So we have the example of nitro and nitrate. Here in case of nitro, nitrogen will act as the donor site. In case of nitrate, oxygen will act as the donor site. So these type of ligands are called as ambidentate ligand. So once again we will be recall the things what and all we studied today. Classification of ligand based on two types. One is donor or acceptor category. Another one is number of donor sites. On number of donor sites we will be studying monodentate, bidentate, tri, tetra, penta, hexa, and it goes on. So on based on donor or acceptor properties, with lone pair of electrons, without lone pair of electrons. In with lone pair of electrons, again two classifications, with vacant orbitals, without vacant orbitals. So again another classification is flexidentate ligands, ambidentate ligands, then chelating ligands. So this is all for this video. We have studied the classification of ligands today. In the next upcoming video, I will bring some other important topics of coordination chemistry. Stay tuned. Thank you for watching this video. If you found this helpful, please do share, subscribe and like this video.